Hi, this is David from MOSA Field Application Engineering Team. It's my pleasure to share IGMP and IGMP Snooping with you. Here is today's agenda. First, I will walk you through what is Multicast. Next, we will go over some detailed behaviors for IGMP and IGMP Snooping. First, what is Multicast? As you can see from the animation for Unicast application and Multicast application. For Unicast application, if I need to forward a string to 3 different hosts, I will need to forward 3 exactly same string 3 times to the multi-hosts, which means repeat sending the same Unicast packet to multi-hosts, and result of that is wasting of bandwidth. For multicast application, no matter how many hosts I have in the network, I will only need to forward 1 package to all the multi-hosts. Here are the advantages of multicast. IP multicast will only attempt to deliver a package to interested users. Since multicast will only deliver 1 string to many users, it is a bandwidth conservancy technology. Typical applications for multicast are video audio broadcast, protocol information exchange, PLC protocol. Now we are going to introduce Layer 3 multicast addressing. Multicast addressing defined as Class D address, which means IP first 4 bytes will be 1110 in binary, as you can see in the following diagram. And the multicast group's address are from 224.0.0.0 to 239.255.255.255. Here are some special reserved group addresses. For example, 224.0.0.1 is for all systems on this subnet, and 224.0.0.2 is for all routers on this subnet. Here is an awareness when assign IP address to a device in multicast. I try to use animations to help you understand the relationship between IP multicast and MAC address mapping. As we mentioned it earlier, when used as multicast, the IP first 4 bits will be 1110 in binary, which will map to MAC address for 3 bytes, 01, 00, and 5E. Next, when mapping Layer 3 to Layer 2 address, only IP last 23 bits map to MAC last 23 bits. So the result of that is 5 bits of IP address not being used. What does this 5 bits of IP address not being used will affect you when assign IP address to the device? Here is the result of 5-bit loss. Since this 5 bits of IP address is not being used to mapping Layer 3 to Layer 2 addresses, the result of that is there will be 32 IP addresses mapping to 1 MAC address. As you can see from the following figure, there are 32 addresses mapped to send their to multicast MAC address. Next, we are going to talk about the behavior of IGMP. Before we introduce IGMP behavior, we would like to give you an overall picture of what would happen when you did not enable IGMP and IGMP snooping. PCs act like hosts, so when one of the PC sends a request to view camera's image, the multicast stream flows back to L2 switch. The stream will flood to every host on this switch, no matter if host wants to view the image or not. However, when enable IGMP protocol and IGMP snooping, first of all, router acts like a courier, will constantly pulling hosts from the group to ensure host is still in the group or not. With IGMP snooping enabled, when one of the PC sends a request to view camera's image, their two switch will only forward the stream to the host wants to see this image. In this case, only PC1 receives the stream. We will explain everything in detail from the following pages. So, what is IGMP? IGMP stands for Internet Group Management Protocol. The purpose of IGMP is to permit hosts to communicate their desire to receive multicast traffic to the IP multicast router on the local network. This permits the IP multicast router to join the specific multicast group and to begin forwarding the multicast traffic onto the network segment. The initial specification for IGMP V1 was documented in RFC 1112, host extension for IP multicasting. Since that time, many problems and limitations with IGMP V1 have been discovered. This led to the development of IGMP V2 specification, which was ratified in November 1997 as RFC 2236. Now, the latest version of IGMP is version 3, also referred to RFC 3376. Here are two features of IGMP V1. One is membership queries, and another one is membership reports. Membership queries means query sends IGMP query message to 224.0.0.1. 224.0.0.1 means the multicast address for all hosts on the subnet. Also, a Mozart's default query interval is 125 seconds. Once the host receives the membership queries, it will send membership reports back to query. Overall, periodically sending general queries to 224.0.0.1 to determine membership is still existing or not. Here are 4 diagrams to show you the behavior in IGMP V1. First diagram, if there is a host wants to join IGMP group, it will send a join report to 224.1.1.1 in order to join that group. Next diagram, the general queries. The router will send general membership query to 224.0.0.1 periodically. Third diagram is basically referred to membership report. Once hosts receive routers periodically membership query message, one member from each group per subnet will send out membership report. Last diagram shows how this query knows if host is still existing or not. Basically, queries will send periodically query message to the host, and if the query does not receive report after timeout, it will start forward to that group. Here is IGMP V1 package format. From the version value, you will be able to see if this is IGMP V1 or not. From the type value, you will know if this package is a query or a report. Overall, this package format will help you understand more about IGMP V1 when you analyze the package. Now, we are going to move to IGMP version 2. Here are differences between IGMP version 1 and version 2. Unlike IGMP version 1, IGMP version 2 has its own query election mechanism. When there are more than one router in multicast network, initially all routers will send out a query, and then the router with lowest IP address will be elected as query, and other routers become non-queries. However, IGMP V1 query will be based on multicast routing protocol or manual defined. The next difference is group-specific query, which means allow the router to only query membership in a single group instead of all groups. The purpose of this is if a host sends a leave message to query can send out a group-specific queries for that group to ensure if there is any members left in that group. The third difference is query interval response time. User can define maximum response time. Default is 10 seconds, which informs host of maximum time within which a host must respond to general query. However, IGMP V1's response time is fixed in 10 seconds and unable to change to other value. The last difference is IGMP V2 offers leave group message. Unlike IGMP V1, queries has to wait for membership query in order to know host leave the group. However, in IGMP V2, host sends leave message when host leave a group. Overall, IGMP V2 device can recognize IGMP V1 packet backward compatible. Here are 4 diagrams to show you the behavior in IGMP V2. First diagram, when host wants to join a group, it will send join report to 224.1.1.1, which is same as IGMP V1. Next diagram. This is how IGMP V2 elect query. Initially, all router sends out a query, and router with lowest IP address elected as query, and rest of the router become non-queries. Third diagram is showing how hosts respond to general queries, which is same as IGMP V1 behavior. Unlike IGMP V1, IGMP V2 offers leave message. When a host wants to leave the group, it will send out leave message. Next, router sends out group specific query, and the remaining host sends out report to remains active. Here is IGMP V2 packet format. From the type value, you can see each value stands for each function, such as hexadecimal 11 stands for membership query, and hexadecimal 16 stands for IGMP V2 membership report, and so on. Since there are few new features added into IGMP V2, from this format, you will find leave message and maximum response time listed in it. Now we are going to move to IGMP V3. IGMP V3's feature is source filtering. What is source filtering? Basically, source filtering allows receiver only receiving package from specific source within a multicast group. So IGMP V3 required to support source-specific multicast. Moreover, IGMP V3 compatible with IGMP V1 and V2, which means IGMP V3 device can recognize IGMP V1 and V2 packets. Here, we are going to use one diagram to show you how source filter works. As diagram shows, there are two different sources going to the router. IGMP version 3 can filter which source to receive and which source cannot receive. As you can see in this case, IGMP version 3 device only allows source 1.1.1.1 to join, so the PC will only receive packets from source 1.1.1.1, but not source 2.2.2.2. Here is message format for IGMP version 3 carrier. As you can see, here is message format for IGMP V3 report. Here is list of table to summarize IGMP version 1, version 2, and version 3. As you can see, IGMP version 1 was the first version, so it offers membership query, membership report, query election, and query interval response time. Since many limitations with IGMP version 1 has been discovered, IGMP version 2 offers query election, adjustable query interval response time, specific group query, and leave message. IGMP version 3 has one new feature added on the top of IGMP V2, which is filtering mode. Regarding to the version compatible, IGMP version 2 compatible with version 1, and IGMP version 3 compatible with version 1 and version 2. Next, let's talk about IGMP snooping. Why we need the IGMP snooping? Before switch supports IGMP snooping, if there is multicast stream flow through layer 2 switch, it will flood the traffic to all the ports, as you can see from the animation. Without IGMP snooping, it will cause heavy loading on the network. Moreover, for those devices that do not need the stream, will result in unnecessary traffic flow. When the switch supports IGMP snooping function, that means the multicast stream will deliver to host who needs this stream. Another way of saying it is when enable IGMP snooping means the switch will filter multicast stream and then will deliver to hosts who needs this stream, which will be more efficiency than flood to all the ports. Here we are going to introduce the IGMP snooping mechanism in more detail. Hope you still remember IGMP behavior in the previous page. Based on this diagram, PC1 wants to join group 224.2.2.2, so it sends the join message to the switch. If the switch enables the IGMP snooping, group address list will record the port's name and switch will transparent the join packet to Multicast router, who is their 3 carrier. Once the carrier router receives the join packet, it will create the group record on its memory. Same as previous page, PC3 also wants to join group 224.2.2.2, so it sends the join message to switch. Group address list will record the port's name, and switch will transparent the join packet to the Multicast router carrier. As we mentioned in the previous slides, carrier will send IGMP carrier message to 224.0.0.1 in every 125 seconds. When carrier sends IGMP carrier message to 224.0.0.1, it will send to all the ports regardless if host joins the group or not. Once the host receives router periodical membership carrier messages, member will send out membership report to router and carrier. At this point, we should note the snooping join and general carrier mechanism. However, if the host wants to leave the group, do you remember the IGMP V2 leave procedures? Let's use the next few pages to help you bring back some of the memory. In IGMP V1, it does not have leave packet, so the only way is waiting for the timeout. And in IGMP V2 and V3, the host sends out the leave packet. After carrier receives the leave message, carrier will send back a specific member query to all the hosts on the same group. If no one responds to that specific member query, the carrier will kick out the group from its group address list. As you can see from this diagram, PC1 sends out a leave message to carrier and router. Once carrier receives the leave message, carrier will send back a specific member query to all hosts on same group. If no one responds to the specific member query, the carrier will kick out the group from its group address list. In this case, carrier sends out a specific member query to all hosts on the same group, which are PC1, PC3, and routers. Whoever left in this group will send back a membership report to indicate there are still members in this group. In this case, PC3 sends out a report to carrier in order to indicate PC3 is still in this group. Even though Topology has faster recovery time, but when it uses with IGMP protocol, it will have slow network failure recovery. Here is the reason. When network fails, carrier won't know there is a disconnection in the path, so it has to wait next query in order to know there is a failure in the path. This recovery could take as long as 125 seconds, since that is query interval time in Mozart switch. When uses IGMP protocol in Turbo Ring network, please enable static multicast query port. Since static multicast query port means forwarding all multicast packets include IGMP. So when network changes, it will still forward the multicast packets to the right host through different paths. Now let's move on to hands-on section. Here is the network topology. Basically, we are going to enable IGMP Snooping function on this layer 2 switch and use those two PCs as hosts to view the image. First of all, enable multicast in web browser or viewer, as you can see in this diagram. All you have to do is find the camera through web browser and then under protocol options, please select multicast. Here is the first scenario. Disable IGMP snooping. The reason that we are doing this is to show you when we were talking about IGMP snooping, we mentioned it, why you need IGMP snooping. Hope you still remember why you need IGMP snooping. If you don't remember the reason, that is alright, cause once you finish this hands-on, you will remember why. First thing you need to do is enable multicast on the web browser or viewer, and then start up Wireshark on both PC to see the result. As we mentioned it on page 25, when there is multicast stream flow through layer 2 switch without enable IGMP snooping, it will flood the traffic to all the ports. Based on this test result, we can tell from the Wireshark or switch's port monitor that stream is coming from port 5 and flooding to port 4 and port 6. Now let's move on to scenario number 2, which is enable IGMP snooping. Based on this result, we can tell the differences between enable IGMP snooping or not. Moreover, you will understand more about IGMP behavior, which is deliver package to whoever joining the group. All you have to do is enable multicast on the web browser or viewer and also enable IGMP snooping. Once you finish set up both, you can start up Wireshark on both PC to see the results. Here is how you enable IGMP snooping. Once you log in the switch, under main menu, you should see multicast filtering. Click on the multicast filtering and then click on IGMP snooping. You should see IGMP snooping setting. Under IGMP snooping setting, put the check mark on IGMP snooping enable. That's it. In this case, only PC2 use web browser to view camera image. From the Wireshark result over switch's monitor port, you can see the stream only flow to the host that wants to view the image. It will not flow to every single port on the switch. Thanks for listening this training. Hope after this training, you will have better understanding about IGMP and IGMP snooping. If you have any questions, please feel free to contact us. Thank you.